I have a fairly interesting story for you this morning. It's titled, At the Solar System's Edge, Voyager 1 Finds a Wall of Fire. That most definitely caught my attention this morning. At the farthest reaches of the sun's influence, NASA's Voyager 1 spacecraft has stumbled across into a region that behaves less like empty space and more like a furnace, where charged particles heat to tens of thousands of degrees. The discovery of this blazing boundary sitting between our solar system and interstellar space is forcing scientists to redraw their mental map of what the edge of the sun's domain really looks like. This is a very interesting story. Apparently, Voyager 1 is now flying through a very dense plasma field. And as I read the story, it gives some pretty specific information in regards to temperature and things like that. So let's get a little bit into it, not too terribly, because I want you guys to read it. It is absolutely an amazing story. A wall of fire at 30,000 to 50,000 degrees Kelvin. The most striking new detail from Voyager 1's data is the temperature of the plasma it is moving through. Analysis of the spacecraft's measurements indicate that the boundary region around the heliosphere is not just warm, but blistering hot, with estimates placing the plasma between 30,000 and 50,000 degrees Kelvin. That range, which far exceeds the surface temperature of many stars' outer layers, have been highlighted in reporting that describes the spacecraft detected at 30 to 50,000 degree Kelvin wall at the edge of our solar system. The first question is, how is the spacecraft not melting if that's the case? But let's take it on its face. So the solar system is surrounded basically by a giant plasma field emitted by the sun. How the heliosphere builds a blistering boundary. This goes through how this happens. This part tells you exactly how Voyager's instruments are actually seeing things and how they're working. Why a superheated edge matters for life and cosmic rays. It's a fascinating story. And of course, I'm going to link it here. But the implications of this are a little bit deeper than what this story really gets into. One of the things I've on and off kept track of is how energy can pass through plasma. One of the reasons I've done this is because I have felt for the longest time that the actual defense against a hypersonic missile or weapon is a directed energy weapon, but you have to have the right frequency to actually go through the plasma field and hit the object. So I asked Google, can radio signals pass through superheated plasma? Yes, radio signals can pass through superheated plasma, but only if the radio wave's frequency is higher than a certain critical threshold known as plasma frequency. The reason I ask myself this, because we keep hearing in the news, we heard this signal from outer space, or scientists are trying to explain this signal, or that. Is it possible that our own signals are bouncing off this plasma field and coming back to us? Maybe not directly, bouncing around, who knows? If the heliosphere, the giant sphere around our solar system, as our solar system passes through the galaxy and through the universe, if that superheated plasma field doesn't allow television, low frequency radio communication to exit, then are we detecting ourselves? Do you all remember the movie Contact with Jodie Foster? And we got our contact from the other civilization, and it was Herr Schicklgruber, because that was the first television signal that went out into space. So they sent back Herr Schicklgruber. Is it possible we're detecting our own frequencies? Maybe. I don't know enough about this, obviously. I'm not pretending to be some kind of rocket surgeon or brain scientist. But what I can say is that this is incredibly fascinating. So basically, we are a plasma ball, and we're the inside of this plasma ball, hurtling through the cosmos. Why is the spacecraft not melted if we're talking about temperatures of 30 to 50,000 degrees Kelvin? How are we receiving these communications? How is this stuff happening? Beyond my knowledge, I assume that it's just reading samples in the distance. It goes through that in the article, and I'm not gonna spoil it. That's why I say, who knows? Because I want you to read it. I actually do know. It says it right here. But I'd like you to read it. It's a fascinating article, and the implications of it are incredible. So we would have to pass through that boundary layer to get into interstellar space. Voyager 1. Talk about getting your money's worth. Seriously, talk about getting your money's worth. This thing was launched in the 1970s, and we're still getting back groundbreaking scientific data. Groundbreaking. This changes the way we view our solar system in so many ways. That the sun's energy is not just basically bled into space. It is powering this plasma field. When you read the article, again, read the article. It's a great article. You read that it's the sun itself that creates this plasma field around the solar system. It's absolutely incredible. This is one of those articles that got me thinking all morning long. I've had it now for a couple of days, and it had me going all morning. I didn't even know where to start. The mind starts racing at the possibilities of what it is, how it is. How is it that we're getting this information without it melting? Obviously, it's not sitting in a 50,000 degree Kelvin oven right now. It's reading this stuff off in the distance. But incredible. And what does that mean for our desire for interstellar travel? We now have to create a vessel that can basically travel through a sun. Is that the implication here? Are we looking for holes in the heliosphere plasma layer in order to transit through? Is it now even possible to contemplate interstellar space until we can figure out a way to land on the sun? See the questions that arise from this? Fascinating. I love this kind of stuff. And a lot of the answers are in this article. Again, I'm trying very hard not to spoil a lot of it because I'd like you to spend your time reading it. It's fascinating. Absolutely fascinating. So at the end of our solar system, at the very edge of space, of interstellar space, Voyager 1, once again, proving to be some of the best money ever spent on space research, giving us more groundbreaking data to sift through for years. Now we have to raise the question, can we even leave our solar system? Is that even possible? How is this not the case with every other star? Is this the case with every other star? Are we able to see the plasma field around these other stars? Is that plasma field interfering with our interpretations of other planets? So many questions come from this, and the only answer that we do have is that we are now a ball of fire hurtling through the universe, which we kind of already knew, in a way. Fascinating article. I hope you all have a chance to read it. It's really worth your time. It's a lot of fun. I want to thank everybody. If you like it, be sure to read it. Thanks.